Hello everyone, welcome to M4 Mathematics. In this video, we'll discuss one more question based on definite integration. Let us see. So, question is find integral 0 to 1 x into tan inverse x whole square dx. So it's a question from integration by parts, in which we should decide which function will be treated as first function and which one will be the second function. So in this case, this inverse trigonometric function will be the first, and x, which is algebraic, this will be treated as a second function. So the rule says first function as it is. So tan inverse x whole square will come as it is into integral of second function. So integral of x will be x square over 2. Limit is from 0 to 1 minus integral d by dx of first function, means tan inverse x whole square, into integral of second dx. So here we'll put upper limit first. So it will become 1 square, that is 1 upon 2, and tan inverse, in place of x first we'll put 1 whole square. So first we have put upper limit minus lower limit is 0. So when we put 0 here, so this whole thing will become 0, minus limit is from 0 to 1. Now we'll differentiate tan inverse x whole square. So it will become 2 times tan inverse x into, and derivative of tan inverse x is 1 over 1 plus x square, into integral of x. So it will be x square over 2 dx. So this 2 and 2 will get cancelled. Now if you simplify here, it is tan inverse 1. Tan inverse 1 is pi by 4. So 1 by 2 into square of pi by 4 will be pi square upon 16, minus integral 0 to 1. So here we are left with x square upon 1 plus x square into tan inverse x dx. Now our main aim is to integrate this part, because this part is already done. So I am considering this part as, say, I1. So we'll simplify I1 first. Now to simplify this, we'll use this method. We'll add and subtract 1 from the numerator, so that we'll get the same expression as we have in the denominator, into tan inverse x dx. So from this step, it will be divided into two different integrals. One is 0 to 1 x square plus 1 over x square plus 1, minus 1 over 1 plus x square, and outside we have tan inverse x. This will get cancelled, so we're left with 1 only. So this will become 0 to 1 tan inverse x dx, minus integral 0 to 1 1 over 1 plus x square into tan inverse x dx. Now this again we need to simplify with help of integration by parts. So what I'm doing now, I'm giving it a name, say I2, and I will simplify it separately. And so whenever we have only inverse trigonometric function in the integration, so we'll treat 1 as a second function and tan inverse x as the first function. So first function as it is, integral of second, that is 1 dx, minus integral dy dx of tan inverse x into integral of 1 dx. Integral of 1 will be x only. Limit is 0 to 1 across, so it's not changing. Throughout the question it will remain 0 to 1 in this case. Integral of tan inverse x will be 1 upon 1 plus x square. For 1 it is x dx. Limit will put in the final step only. Now in this case we'll put 1 plus x square as t, so that it will become 2x dx is equals to dt. So x dx will become dt by 2, and when we integrate it, dt over t, so by 2 is already there, so it will become half, and 1 upon t, it will become ln. And limit is from 0 to 1 across. So this will be the value of I2. So we will put the limits. First we'll put 1. So this will become 1 into tan inverse 1 minus half ln. In place of x we'll put 1. So 1 plus 1 square is 2. So it is ln 2 minus, then we'll put lower limit which is 0. So this will become 0 and this will become 0 as well, because ln 1, when we put 0 in place of x, it will become ln 1. Ln 1 is 0, so this part will remain 0. So it means for I2 we will have this value 1 into tan inverse 1 will be pi by 4. Tan inverse 1 is pi by 4 minus half ln 2. So this will be the value of I2. So now we will use this value of I2 here, so that our integral will become, now this is pi by 4 minus half ln 2. And now we'll integrate this part. So here you can see that tan inverse x is given, and with tan inverse x its derivative is also existing here. So if we put tan inverse x as t, I'm just showing you here that how to go with this. I'm putting tan inverse x as t, so dt by dx will become 1 over 1 plus x square, or we can say that dt comes as dx over 1 plus x square, right? So this whole thing will become t dt, right? So t dt means when we integrate it, I'm not putting limits because when we have changed the variable, limit should also change. So I'm not changing the limits even. In the next step, when we integrate this t, Then we'll put it back as tan inverse x. So this is pi by 4 minus half ln 2 minus, and when we integrate t, it will become t square by 2, and then I'm putting in place of t tan inverse x. So it is tan inverse x whole square by 2. Limit is from 0 to 1. Pi by 4 minus half ln 2 minus half I'm pulling out. Then I'll put 1 in place of x. And rest of the part will become 0. So that I'm not putting here. So I'm just making it 0 because tan inverse 0 will be 0 only. And its whole square. So now it is pi by 4 minus half ln 2 minus tan inverse 1 will be pi by 4, and when we square it, it will become pi square upon 16. So this is the complete value of I1. So my main integral, which I am giving a name, say I. So I will be, already we have pi square upon 32, pi square upon 2 into 16 is 32, pi square over 32 minus value of I1, which is this. This is also pi square upon 32. Now we open the brackets. I'm just removing it now, it's not required anymore. Minus minus plus. Simplify this. We'll put our final answer here. So pi square over 32 plus pi square over 32. This will become 2 pi square over 32 minus pi by 4 plus half ln 2. It will become pi square over 16 . So this will be the value of this given integration. In the next video, you will find one more question based on definite integral. Keep watching my channel. Thank you.